Hello, students. This is Saxon Algebra 2, Lesson 36. Part A is called contrived problems. We've talked about contrived problems in class before. The word contrived means carefully planned. And so it turns out that contrived problems are problems that are carefully planned to build your math skills. You've been doing contrived problems since first grade. Part B of this lesson is called the multiplication of rational expressions. You will remember that ratio is one synonym for fraction. And rational expressions are mathematical expressions that can be written as a fraction of integers. Now, the book very helpfully presents this reminder of how to multiply fractions together, multiplying the numerators and multiplying the denominators. But I would like to take you one step further and remind you that these are factors in the numerator and factors in the denominator, and you can cross out common factors. So you've got a 4 and you've got an 8 here. So you can cross out the 4 and the 8 becomes 2, the 4 becomes 1. And so the answer to this fraction is 7/10. With that in mind, let's look at example 1 in the book. Example 1 presents us with something that looks a lot more complicated than that little multiplication problem that I just showed you. It presents you with x squared plus x minus 12 divided by x squared minus x minus 20 times x squared plus 2x minus 35 divided by x squared plus 9x plus 14. Now, the first thing I like to do is this fraction bar operates exactly like parentheses. So I like to add the parentheses in so that I know what goes together as a factor. Now, obviously, we cannot cancel out any of those factors because they're all different. And imagine what how Mendoza it would be to multiply those all together. And it would be very Mendoza, very troublesome for those of you who don't speak Japanese. And so we're going to apply the sum and problem game and factor those trinomials and see what happens. So the first thing we do is we factor this one, x squared plus x minus 12. Minus 12 can be achieved with plus 4 and minus 3, and plus 4 minus 3 is x. Below that, we have x squared minus x minus 20. Minus 20 is minus 5 times plus 4, and minus 5 times plus 4 gives you your minus x. Over on this side, x squared plus 2x minus 35. Minus 35 is plus 7 times minus 5. And so we can factor that trinomial that way. And plus 7 minus 5 gives us the plus 2x. This one, 14, is 2 times 7. So we can factor that trinomial, x plus 2 times x plus 7. And now look what we have. We have factors to work with. And with factors to work with, we can probably find some that we can cancel. And yes, right away, we can cancel these x plus 4s. We can cancel these x plus 7s. And we can cancel this x plus 5 with this x plus 5. And that leaves us with the grand answer of x minus 3 divided by x plus 2. Who would have thought that complicated looking problem would have such a nice, simple solution? On to part C, the division of rational expressions. We've already gone through rational expressions. We know what they are. The book provides this very handy reminder of how to divide fractions if the division problem is presented to you like this. You know that x divided by y divided by k divided by p is equal to x divided by y times the reciprocal of k divided by p times p divided by k. And so your final answer is xp divided by yk. So we are about to apply that to the one and only example that they have given us for this section. And here it is. X squared minus 6x plus 8 divided by x squared plus 3x minus 28, all divided by x squared minus 2x minus 15 divided by x squared plus 2x minus 35. Now, I think you're all already on to the fact that we are going to factor those trinomials and be able to cancel things out like crazy. But what we're going to do first is put those parentheses around it to remind ourselves that these things are all go together. However, since this is a division problem, before I factor the trinomials, I want to change it into a multiplication problem. So you'll notice that this is exactly the same, but I have used the reciprocal of this one. So now we have x squared minus 6x plus 8 divided by x squared plus 3x minus 28 times x squared plus 2x minus 35 divided by x squared minus 2x minus 15. And so let's go ahead and think about how to factor x squared minus 6x plus 8. 8 is 4 times 2, or minus 4 times minus 2. And so if we use minus 4 times minus 2, we're going to get that minus 6x, and we're hunky-dory. The bottom one, x squared plus 3x minus 28. Minus 28 is 4 times 7. So we want a minus 28. So if we do plus 7 minus 4, we're going to get this plus 3, and we're going to get that minus 28. X squared plus 2x minus 35. Minus 35 is 7 times 5. We want a minus, and we want a plus here. So the 7, x plus 7 times minus 5 gives us plus 2 and minus 35. Finally, x squared minus 2x minus 15. 15 is 3 times 5. We want a negative, so it's going to be x minus 5 times x plus 3, and that's going to give us the negative 2x and the minus 15. And there we are, ready to go and cancel out those factors. X minus 4 can go. X plus 7 can go. X what did I do wrong? X plus 7, x minus 5, x minus 5. I wrote this wrong. No, minus 1, x minus 5, x plus 3. X minus 5 can go. And so the final answer is x minus 2 divided by x plus 3. And I just noticed that there's one more example on page 165 for you. I think that all of you can follow that example and work on the practice problems and be all ready to go with this, mastering this lesson. I hope this video helped despite my little problem there, and we'll see you next time.